Hey there, folks. So, last episode we went through and did some work on our inventory and mainly the UI aspect of things. We've got things set up now where our inventory is showing up, it's filling the screen, and we added in the buttons for use drop. However, we haven't had any logic added to those yet. However, I know I said this episode was going to be expanding on the inventory system, but I've actually reached a point where I do need to do some decision making on how I want to move forward with the inventory. And with that, because it's going to take me a little bit of time to figure out how I want to implement the inventory with the use, drop, things like that, I've decided I'm going to put the inventory system on hold for now. And I'm going to switch over to working on the Chronomanager that I mentioned in the previous episode. And that should give me enough time between recordings to figure out how I want to move forward with the inventory system. So, to get things started with the Chronomanager, we're just going to go over to our C++ classes, the fall, or your project folder, public, base classes. And because our TF actor implements all of our save game logic already, we're going to do a derived class from that. So right click, create derived C++ class derived from TF actor. And this is going to be called TF Chrono, lowercase h there, Chronomanager, manager base. So we're going to create that class. Now, before we go through and reload things, there's actually a couple of structs we want to create as well. Just because I want to continue following how I've done it before, where I have specific files for data types. So I'm just going to wait for all of this to finish. And what I'm going to do is I'm going to pause the video while it does the loading for the Chronomanager. And I'll be back as soon as we're going to start working on creating the data types. All right, so that's compiled and we're back into the editor. So because we're working with the data type folder, which isn't actually present in the folder structure, we just go into our public folder within the C++ classes, right click, new C++ class, and empty, click next. On the folder on the right there, click that and select your data type folder. That's going to make sure all your files are created in the right locations. The first one we want to create is ftime. You're going to let me type. Apparently the editor is being slow. ftime data. And that's going to be a struct. So we're going to create that class. And the editor, no, ignore this one. And then we're going to go back to our editor. And we're going to repeat the process. Oh, live code is trying to run. So cancel that. New C++ class. Again, none. Create next. Click next. Again, select your data folder so it goes into the right location. And come on. Wakey, wakey. Oh, this is being so slow. So on this one we want E, because it's going to be an enum. So E day length, if I could spell. And then we're going to click create class on that. Now this time around when the editor hits reload, prompts for the reload, we can hit yes, reload all. Do you want to stop debugging? Yes, because we're not going to be doing anything else in the editor this episode. Everything's going to be covered. Well, everything's going to be in the code. Just quickly, we're going to just clean up these two classes that we created because they're not actually classes. Get rid of that. And we're also going to want to just make sure we do the same thing we did with our other data types. You need to include your data type name.generated.h in your header file. So in the day length, it's going to be include e day length dot generated dot h, and in our time data, it's going to be include f time data dot generated dot h. So quickly going to populate these two. You're going to have these errors because they don't actually exist yet. They will exist as soon as we go to do a build. And actually, we're just going to fix that quickly. We'll just do a quick build here. And this should automatically create these two files. Oh, no. Okay, we got to comment them out first and then do a build. Sorry, this was one of the corrections I made in the middle of an episode. Episode 23, where we created all of these. So let's just cover that. Build those. Okay, and now they should... Actually, they might not... Yeah, because we don't have any functionality. That's why they're not being generated. So anyways, we're going to start with our ftime data. That's a struct. And we're just going to fill this in. ustruct blueprint type struct ftime data. Open that up. No, wrong brackets. Generated ustruct body. So I'm just looking at my other code here. Yeah, no. So that was generated ustruct body. And then this is just going to be pretty basic here. These are going to be public. These are going to be u property. Visible anywhere. Blueprint read only. And just for ease, we're going to put a save game tag on these. I'm going to copy that u property decorator. So it's going to be int year equals 0. Int month equals 0. Int day equals 0. You can probably guess int hour equals 0. And finally int minute equals 0. Actually, I want to give these a better value, so I'm going to use today's date, 2024. Oh, what is it? July 28th. So month is 7, day is 28, hour, I'm just going to set this at 12 noon. So that's all we need to do for the struct. And then just for the day length, this one is an enum, and it's going to be used for determining how long in real world minutes one game day takes. So what we want here is uenum blueprint type, and then we want meta equals bit flags. And the reason for that is we are adding a predetermined code level mapping value. So enum class e day length, and as with all enums, it's derived from uint8, and then we want default equals 0, min 30 is 1, min 60. And the reason why it's min 60 instead of 60 min is an enum has to start with an alpha character, not a numeric. Equals 2, min 120 equals 4, min, let's just go up to 300. 180 equals 8, min 240 equals 4. That's 6. 2, 4, 6, 8. min 300 equals 10. Now, I would recommend for something like this, because you can't use a numeric as the first value, add in the U meta. I actually just copied this out from my other iteration of this. Actually, I'm just going to copy all of this over, save me doing this one at a time. So what this is saying is min 30 actually is going to have a user-friendly name of 30 minutes, 60, 120, 180, 240, 300. All right, so we've got those. So we're going to save. And we're going to do another quick build here. And this may take a moment. So I'm actually going to pause. Oh, no, it's moving. 6 actions. Day length. Let's see. No, this is taking a moment. So I'm going to pause the video and I will be back as soon as the build is complete, because I want to get those extra. Oh, there we go. Oh, what have we got failed here? F time of day. What is it complaining about? Missing tips are assume default int. That is correct. Why are you not? Is that because I'm missing the extra include? And these are some of the weird behaviors I found with Unreal Engine. So, okay, compile this time. There you go. Okay, so it was because I was missing that include. So we're going to do the same thing for our day length. That shouldn't be needed, but we'll add that just in case. And then we'll see. So no, I sort of really quickly glossed over creating these custom data types or independent data types in that quick addendum I did in that video. So I want to make sure I at least cover some detail of that here. Okay, so we have those two. Now what I'm going to do is I'm just going to close out of those headers because we don't actually need them. I'm going to leave the source files open simply because I'm going to be grabbing the includes for ease. In our Chronomanager base header, I'm going to put those in there. So we have E day length and F time of day. And now we've got those, we can get rid of the header file, or sorry, the source files. We don't need them open either. So within the Chronomanager, we are going to need to have some references. So first of all, we are going to need to, actually I'm going to put these in here: private, protected, and public. So in the private section, we're going to want to include, obviously, that new struct we just created of F time data. So U property visible anywhere, blueprint read only, and save game. And then also we're going to need the meta equals allow private access equals true. Now this is something I should have done earlier on in the series and something I'm going to be going back and fixing, but there's some other attributes you want to add here. As I've mentioned before, you want to try and think about this in a way of you're not always going to be the only person working on the project. Even if you know like 100% it's going to be a solo project from start to finish, I would recommend approaching this in a way that it's not going to be a solo project, and you want to add things in that are going to help other developers, designers, things like that. So one of the things you're going to want to do is start adding in things like this: tooltip, current time of day information. And what this is this is when you mouse over the name that is displayed within the details panel, it gives you that little tooltip pop-up. Well, that's what this information is. And the other thing I want to start doing is categorizing my variables a little better. Category, if I could spell, equals, and we're going to go chrono, just because it's dedicated to this. And then if you add a pipe, it creates a subgroup, and this is just going to be time. I'm going to copy this, even though that tooltip's not value for everything. And this is going to be f time of time data, current time. Actually, I'm going to want to do something before that. Use day night cycle, and we want a boolean for this, so bool be use day night cycle, and I'm going to default this to true. So we've got that. Now, with the way I'm going to be implementing this, because we are not using a one-for-one scale of 1 second in the real world as a predefined value in game time, we're going to need to be able to adjust our tick rate based on that. So there's a couple other variables we're going to need. These are not something we want to expose to the editor. They are literally just for the math logic in the background. We want a float. How do I want to name these? Minute decay, no, time decay equals 0, and float minute length equals 0. We're going to be setting these as part of a function, so you don't have to worry about that. Now, we want to add our tick, because that's the main thing about this is going to be tick. I'm just going to copy that over because it's a default one. And we also are going to be wanting our begin play, because we're going to be calculating how long a minute lasts as part of our begin play. So I'm going to throw that into our protected section. I'm just going to create those definitions quickly before we start going through. And then we're also going to want to have, it's actually a bunch of different functions I've done just for the purposes of each function does one particular thing, the KISS method. So we need void update. Oh, how did I do this? I think it started at the year and go down, or no, minute and go up. Update minute. Void. Actually, sorry. Void update time. I'm going to take a const float reference. As I mentioned before, the whole reason for this is just for memory management. Delta time, update minute, update hour, void update day, void update month, void update year. So got all of these functions in place, so we're just going to quickly create the definitions for these. Can I actually create that? What did I click that it's now? There we go. Clicked something it didn't like. So these are going to do exactly what you think they are. It is going to be used to update the respective value within our current time struct. But because it's private, we're not worried about it being exposed. So right now, this is all we're going to be covering. Actually, sorry, there's one other function we need to add, and that is the calculate day length. Void calculate day length. And this is why we wanted to add the begin play function. So quickly expand that and define it. So begin play, we're going to calculate day length. Calculate day length. And our tick is going to just call update time, delta time. And actually, sorry, I'm getting way ahead of myself. Actually, this is the second time I've recorded this episode. The first time, apparently, my mic didn't work. So, up here in our internal ones, we want a bool time was updated. And we want this to be false. So, okay, so we're going to call update time with the delta time. And from here, we need to... yeah, actually, I'll do that. We're going to use these two, time decay and minute length. So what time decay is that is a tracker for the next time we need to update the current minute. And what we're going to do here is time decay minus equals delta time. And then if time decay is less than or equal to 0, we want time decay plus equals minute frequency, minute length, sorry. Now the reason why we're setting this to plus equals instead of just equals is this right here can result in a negative number. So it could be like negative 0.02. We want to account for that. Otherwise, you're going to have like these odd time jumps where 1 minute is of game time is 2 seconds, the next is 3, one is 2.25, things like that. So, and then we want to go advanced. Oh, I called these update. I didn't want update. I wanted these to be advance. Advance minute. So I'm going to quickly fix these, because we're not updating, because update implies you're setting it to a new value, where advance is increase the value. And that's the reason why I want the terminology to be specific. So, and I would normally just do a find and replace for this. However, because we have the update time, I don't want to do that. And I can just copy paste this easy enough. Okay, so after we've done this, we're going to call the advanced minute. Advanced minute. Now this is where that Boolean comes in for the time change. So time updated, time was updated, sorry, was updated equals true. And we're going to get back to what that's actually used for a little later on. Current time dot minute plus plus. If current time dot minute is greater than 59, because there is 0 is the first, 59 is the last. When it rolls over to what would be 60, that's the next hour. So if it's greater than 59, current time dot minute equals 0, and then we're going to go advanced hour. This pattern may be fairly repetitive, but again, same thing. We're going to say the time was updated. Now we are setting that every time. The reason being is you could have, like this time was updated, we're setting it every function. The reason being is you could have an event, like an event manager that reaches out to your chrono manager and say, okay, skip ahead 6 hours. Which means this is going to get bypassed, but this will be hit. So you want to make sure each one of these is set up to indicate there was a time change. So, and this one isn't much different. It's going to be current time, if I could spell, current time dot hour plus plus, and very similar logic. If current time dot hour is greater than 23, it's because we're going to be using military time for this. It is much easier than trying to add a further flag to our that's the source file, not the header, to add something in here to represent AM or PM. So just use military time, which is the 0 to 23:59, and that will limit some of the data storage you need to do. It does mean you have to do some calculations for getting 24-hour time or 12-hour time, but that is something we'll be covering a little later. So then, well, this one's easy. It's current time dot day plus plus, and oh no, sorry, that's time dot hour equals 0. Advance day. If I could spell. Advance day. Yeah, I can't spell. So, same thing again. Now, this one, though, does have some additional logic, because we can't just go, oh, if the day, well, you could, if the day is over 30. If you want to just run on a generic calendar of 30 days every month, that's perfectly fine. But because I'm wanting to try and have some real world accuracy here of January's 31, February's 28 or 29, depending on a leap year, so on and so forth, we need to have some additional logic here in our advanced day. So what we're going to be doing is current time dot day plus plus, and then now we're going into a switch statement. So switch current time dot month, because it's based on the month as to which or how many days there is. So we've got case, and I'm just going to type these out really quick. January, February, March, April, May, June, July, August, September, October, November, December. So, and then we want to default, just in case. I'm going to throw a break at the end there. Now we know January has 31. We know March has 31. So we're going to actually rearrange these, and we're going to take advantage of a C++ switch statements fall through functionality. So we want, okay, so March, and then May on the fifth month has it. Not cut it, not copy it. And then we have it again in July and August. Both have 31 days. October has 31 days. And December has 31 days. So we already know what this is going to be now. So it's if current time dot day is greater than 31. We know we need to loop through to a new month. So it's advanced month. Advance month. We are not no, we can do that here as well. I was going to say, actually no, because all of these are going to, well, all of these, there's 3 cases. Actually no, we'll do it here. So current time dot day equals 1. Now instead of going back to 0, we want this to be set to 1, because we're going to follow like calendar days with this, where it's the 1st to the 31st are our max values. We're going to leave February for now just because it's a slightly more complicated one. Down here, we're going to be saying if it's greater than 30. Oh, I'm going to throw a break in there as well because we're done. And the same thing here, break, and then to do here, actually quickly, log invalid month state. Now for February, this one's a little different because again, I want to account for leap years. Well, that's a pretty easy way to do it. So if current time dot year modulo, that's divided by for the remainder of. If when we're dividing it by 4, it divides equally, is what we're saying there. If current time dot day is greater than 29, then we want to current time dot day equals 0, advance month, and then break. Else if current time dot day is greater than 28. I'm just going to copy this because, oh, nope, not current day equals 0. We want it to be 1. Again, I just said that. And break. So what this is doing, and you can check if you want, but if the calendar year is divisible by 4, it's a leap year. So if this is true, we can say, okay, we need to look at more than 29 days in February, then we're rolling over. If this is false, we only need to look at 28. So that is setting our advanced day logic. We've got our advanced hour, we've got our advanced minute, and we've just got our update time functionality. Now we need to do our advanced month. This one is pretty basic. Actually, did I put that in advanced date? Yes, okay. Time was updated equals true. Current time dot month plus plus. If current time dot month is greater than 12, current time dot month equals 1, current time dot year plus plus. We don't actually need the advanced year function. No, I'm going to say we do, just because you could have events that trigger based on a new year, and we're going to be using that to like you could have, like I was mentioning before, the event manager that says, okay, we're going to skip forward 10 years. So advance, if I could even spell the word, advanced year. And right now it's going to be pretty basic. Current time dot year plus plus. We also want to include that though. So because there is no logic we need, a year will just continue. I don't have expectations the game is going, like, at least with my game, I have to worry about things like millennia changing. Okay, so we've got that done. Now we do need to set up this calculate day length. That's actually the last bit of functionality we need to do before we do a quick test of this to make sure everything's working. So in here, we're going to set minute frequency. Is that, no, what? Minute length? Yeah, minute length, sorry. Minute length. I can't spell. Wow. Minute length equals, now this is where PEDMAS, BODMAS is important, equals oh, I missed a variable. Float day length in minutes equals, I'm going to start this as 10, and I'm actually going to make this one a debug value we can edit. Equals, okay, so day length in minutes multiplied by 60, divided that by 1440, and then time decay equals minute length. So we've got everything there. Now I know we set up that day length enum. We haven't made use of that yet. That is going to be something we'll be addressing in the next episode. But this is all of the basics we need to get things going. I just want to make sure F-time data is something we'll be able to see in the editor. Visible, yeah. Okay, so we're just going to do a quick build here. Hopefully this builds fine the first time. I don't think there's anything I've done wrong here. All right, there we go. So that built. Just going to launch into the editor quickly. Hopefully this doesn't take too long. All right, so now we've got that. We're going to bring our content browser over, go into our project file folder for the content area, blueprints, dev, and then right click new blueprint actor, or blueprint class, sorry. And we're just going to type in Chrono. You can see TF Chronomanager base, and just like everything else, dev BP Chronomanager. So I'm going to save that quickly. I'm going to move this just out of the way. I'm just going to drag that into the world. And you can see here we can view the current time. Now, a day length of 10 minutes is pretty long, so I'm actually going to reduce this down to just something really short so we can watch this go by. We're going to play an editor, Chrono. Oh, we forgot to hook up our tick event. Or I forgot to hook up the tick event. So I'm going to go back to our Chronomanager. No, I did. So, okay, what's happening here? Play. It's not ticking. Because I've got the breakpoint. You can see right here. Constructor. No, why is it? I think it's because we're missing the super. That's why. Begin play, super, begin play, and super tick. Delta time. Okay, let's try that again. So, again, as I mentioned, every episode I make a mistake. I keep these in just because I want to make sure if anyone else is having similar mistakes, they're following along and they make the same mistake I did, you have a rough idea. Right here, I think this is the reason, is we didn't have the super. Hit play. Come on. Oh, no, I didn't save it with the Chronomanager in the level. So just do Chrono. Yeah, it's not there. So BP Chronomanager. I'll actually save that so it stays in the level. Try this again. We'll hit play. And there we go. Okay, so it has hit that. I'm going to get rid of that breakpoint. We don't need that hitting every time. But that other one should be hitting. Well, let's see. Shift F1, Chronomanager. Again, nothing. Oh, no, there we go. You see it's going through, but it's on that 10-minute cycle. So, okay, let's drop this down to, as I was saying before, 0.05. Save. I'm going to play there. I'll select our Chronomanager again. And you can see our minutes and everything are flying by pretty quickly. And rolled over to the next day. I'll just wait until this goes through to August just to make sure. So, coming up to the 30th. Actually, I want to make these editable, but that's besides the point here. Let's actually make this even quicker. So this flies through as fast as you can. And this is actually dynamic because this is something, isn't dynamic because we are not recalculating the day length. You'll notice this is not getting any faster or slower based on that. But you can see we've rolled over to August. It's the 1st. It's still the same year. Everything else is going through. So with that, though, folks, this is the first part of the Chronomanager done. As I mentioned at the start, the Chronomanager is going to cover things like time of day, the year, your calendar date. It's going to also be used to control your directional light for movement of the sun across the sky. Potentially, and I'm toying with the idea of I also want to include like a moon aspect as well. But with that, that's a little more work than I'm wanting to do at least these early stages. That may be something we add in later on in the series as this would be a nice addition. But as always, though, folks, any comments, questions, suggestions, concerns, please throw them in the comments below. I respond to all of them. Thank you for watching, and I will see you in the next episode.